Now that we've seen how to make measures of central tendency in R, let's take a look at how to make measures of variability in R. So recall that in an earlier video, we created a data frame called datasets that has the contents of a GSS 2012 dataset. Let's take a look at the namespace again of that dataset. So if we just go to our output window, we can see that we have several variables that we can work with here, like year and ID, child's age, education, father's education, degree, mother's education, sex, race, and so on. A number of different variables to work with. Let's start with the index of qualitative variation. Now, unfortunately, the index of qualitative variation is not something that R calculates automatically. So we're actually going to have to create a new function that calculates the index of qualitative variation. And so I'm going to create that new function. I'm going to call the function Iqv. Iqv is going to be equal to a function. So I'm going to use the function command to indicate that I'm making a new function. It's going to take one argument. The argument I'm calling var. Basically, the one argument that's going to be created is some kind of a variable on which I'm going to run this function. Now, the lines of code that are included in this function are going to be between these curly brackets. So everything basically from here to here is a part of this function. It's going to be run as part of this function when I run the function command later after creating it. So the first line basically is going to make a table of the variable, and it's going to store it in an object called table. I'm also going to get the sum of the values of the table, which is going to give me a new object I'm calling n, which is going to be the number of cases. I'm going to initialize the values of some new variables that I'm going to create. I'm going to create two of them. Perk.sqr, or percent squared, I'm going to set to 0 at the onset. And I'm also going to create another value for sum of perk squared. That's also going to be set to 0. This is the sum of the squared percentages, which are two things that are going to be used in the calculation of the variable. Okay, so for the next part of this function, I'm going to create what's called a for loop. So a for loop is basically something that continues to run for as many times as the value on which it's being looped is still valid. And so I'm going to be running this for loop on a new programming variable. I'm going to be called I. And it's going to run as long as I is in a value between 1 and the number of rows of table. The number of rows of table is just going to give me some count of the number of categories of the variable. And that's going to vary depending on the variable. So if the variable has 4 categories, the table is also going to have four rows. And then the number of rows in the table is going to be 4. So this for loop will run 4 times, basically. Okay, so whatever is run in the for loop, within the for loop, that is going to be found within this set of curly brackets. And so here's what's run within the values of the for loop. So first of all, I'm going to create a percent value. And I'm going to create a percent value for I. So in the first iteration, I is going to be equal to 1. So this would be the first row of percentages. And it's going to be equal to the value of table, which I created from the table of the variable. But it's going to take the ith value of that table. That is in the first iteration, the first value, because I is going to be equal to 1 in the first iteration. And so I'm going to take basically the frequency value from the first category, and then I'm going to divide that by n, which is going to be my number of cases, which I calculated up here, multiply it by 100. That's going to give me the percent for the first value. And then I'm going to create a square percent. So I'm going to take the percent for that first value, I, square it, and I'm going to save it as perk square I. And this will be the value of the percent squared for the first case. And then I'm going to create a running total. So I'm going to create a new variable called sum perk square, which I initialize as 0, which is going to be equal to the initial value of sum perk squared, 0, plus the value of perk squared, right? And so that's going to be the squared percentage of the first category. And then what I'm going to do is I'm going to create a category that's equal to k, but that's going to be run outside of the loop. Now, the loop's not really finished yet. The loop is going to go from the first value to the second, and it's going to run through this all again. So it's going to create the percent of the second value by taking its frequency, dividing it by the number of cases, multiplying it by 100. It's also going to create a percent squared for the second value, and it's also going to iterate the value of the sum of squared percentages. And I'm going to do that for all values of the variable from I to whatever the number of values in the table is going to be. And then when I'm done, I should have the sum of the squared percentages as a running total of all of the percentages squared. And then I, which is just the pointer variable, is going to be equal to the number of values in the table, basically the number of categories of the variable. And I'm going to save that as k. And so here I've got some things just commented out. I was just using this when I was creating the function. I printed the value of k, the value of n, which is the number of cases, and then the sum of squared percentages, just to make sure that I was getting the right values. But I've commented them out, so they're not going to be printed in the output when I run the Iqv function that I'm creating. At this stage, I'm going to create an object called result. And this is basically going to be equal to the value of the Iqv when I run the Iqv through the Iqv formula. So remember, the formula tells me to take in the numerator k, the number of categories, times 100 squared or 10,000 minus the sum of squared percentages. And in the numerator, denominator, I have 100 squared or 10,000 times k, the number of categories, minus 1. So if I run that and then I print the result, it should calculate the Iqv for me, and it should do it automatically when I run this function. So I'm just going to highlight all of my function. I'm going to run it. R is going to recognize this as a new command, and then I can basically use this as a command in my data analysis. And so I'm going to run this new command on some variable. In this case, I'm going to run it on the value of class, which is found in the data set data frame. And so if I run this, and I look at my output window, notice that it calculates the index of qualitative variation, which in this case is 0.81, let's say 2, if I round it. So 82% of maximum possible diversity in the class variable, which is quite a lot of diversity. Okay, so that's the interquartile range, index of qualitative variation. Let's look at some other measures of variability. So now let's look at some measures of variability for an interval ratio variable, education. Okay, so one thing I can do is I can just use the summarize command to look at this education variable because I want to make sure that it doesn't have any missing values, right? So I'm going to cbind the summary statistics so they're all matched up by column, and I'm going to print the results showing only 2 digits. So if I run that, and then I look at my output window, so I can see that I've got like the minimum of 0, first quartile of 12, the median is 13, the mean is 14, 16 years of education is the third quartile, the max is 20, and I have 2 missing values, which it doesn't use in the calculation. Okay, so that's basically how I can get the quartiles and the median. That's part of what I would look at as measures of variability, but I also want to calculate some other values. So going back to my script, I can also calculate a variance. I can do that with the var command. So var just takes a couple of arguments. The first one is basically just the variable on which I'm running this command. So it's education filed into dataset data frame, again separated by a $sign, and then I'm going to use the na.rm option set to true to exclude any missing cases. Now, if I didn't do this, the resulting value in the event that I had missing cases, which I do in this case, would just be NA. So make sure that you include that option. And then if I look at my resulting value, I have a variance of 9.77. And then, of course, that's in a square metric, so it'd be more meaningful if I calculate the standard deviation. So going back to my script, I can use the SD command to calculate the standard deviation. Again, I'm going to do it on education. And again, I'm going to make sure to exclude the missing cases. If I run that, go back to my output window, I see that I have a standard deviation of 3.13, if I round, years of education as my standard deviation. Okay, another thing I can do is I can actually use the by command to do this for the same kind of thing for separate groups. So let's say that I wanted to run separate descriptive measure of variability as descriptive statistics for men and women. And so let's say I wanted to do it on education. I would use the by function. I would tell it that I want to run it on the variable education found in the dataset data frame. I'm going to do it separately for men and women, so I tell it the grouping variable next. Here I'm going to use basically an unnamed function, and the function I'm going to pass is basically the summary command like I did earlier up here. And I'm going to do this for basically both men and women on the variable education, excluding any value of education that's missing. So if I just kind of run this, and I scroll down here to my output window, I can see that I have separate values for sex equals 1 or men, or sex equals 2, which is women. And so I can see the minimums are the same as the first quartiles, the medians are the same. Looks like the mean's a little bit lower for women than it is for men, but they're very close. And they have the same third quartile and the same maximum value. Okay, so next we're going to look at how to make a box plot in R. And so the first thing I'm going to do is I'm just going to make a table of the values of education sum to get the total number of cases. I'm going to use the print command to show how many cases there are. If I look at the output window, that turns out to be 1,972 cases. That'll be informative for the note that I'm going to add to the bottom of my box plot. And so going back to my script, here's the syntax for the box plot command. The command is box plot. The first thing that I have to include is the object on which this command will be run, that is the value of education in the data frame data set. I provide a label for my y-axis that's going to be education in years. The x-axis is just going to be one box plot, so I don't need to label that. I'm going to include a title with the main option. Notice that these are all, again, separated by commas, which is a pretty common convention in R. And then I'm just going to add a note at the bottom of the table telling us how many cases we had, which we calculated right here. And then we have a end of line character and the source and another end of line character. So if I run this and I scroll out, I can see that R created the box plot. So it kind of looks like it's more or less symmetrical, but only if we ignore these circles which indicate outlying observations. If we don't ignore them, actually this tail would be a lot longer than this tail, so this looks like kind of a negative or left skew. Looks like the box is sort of between about 12 years of education and about 16 years of education. The median looks like it's about 13. The maximum is 20. The minimum would be 0, but it actually looks like it's closer to 6 if we ignore these outliers. So a conventional box plot would actually extend this whisker all the way down here, but in R, these are actually flagged as being outlying observations. That is, they're very different from the rest of the data. So again, we can kind of just export this, save it as an image, and then we can import it into another kind of document and write a report about it or whatever we want. Okay, so going back to my syntax, let's actually see how we can make a box plot and descriptive statistics for education separately for men and women. So first of all, why don't we make a label for men and women? It's going to be a vector that's going to take on the values of either male or female. If I want to figure out the total sample size for men and women, I just run another by statement. I run it on the variable education in the data frame data set. The grouping variable is going to be sex in the data frame data set. I'm going to have a nameless function here, which is going to calculate the length of anything that is not missing, which just basically tells me to select only those values that meet some criteria, and the criteria is that they're not missing. So this is going to count all of the number of non-missing cases separately for men and women. So if I go down to my output window, I can see I have 884 men and 1,088 women. That's useful information to put into my box plot. So if I go back to my syntax, I'll show you how to make a box plot separately for men and women. And so again, the command is box plot. The variable on which I'm making a box plot is education within the dataset's data frame. I can use a tilde to indicate that I'm going to be making separate box plots for men and women. That is, I'm grouping by sex. And then the names of the box plots are going to come from my sex label vector, which I created here. So sex labels. And then I'm going to label my y-axis. The names are already going to be put in on my x-axis automatically, so I don't have to do anything more for that. And then I just give it a title. I'm going to call this the box plot of highest degree earned by sex. And then I'm going to put a note or a subtitle at the bottom of the graph using the title command, in which I indicate the number of men, the number of women, the source of the data, and I'm going to left align it so it doesn't look all cluttered. So I just highlight this, I run it. If I scroll out, I can see that now R has created 2 box plots. one for men, one for women. They look virtually identical, so the distribution is pretty much the same. And I've got all the information that I asked for. The node information is left aligned like I recommended. And so basically I've shown how to create measures of variability in box plots in R.